There we go. Hello, can you hear me?
Yeah, I can hear you fine.
Perfect. Oh, that would be nice. All right. Okay. I'm the President's Club. I talked to you yesterday. I will not be leading the interview though. I have to deal with a few stuff. So Pratik will lead the interview. Say hi, Pratik. There you go.
All right.
I'll plug in. So yeah, you can go insert whenever you're ready.
I'm just gonna like move the camera a bit.
Yeah. Go for it.
All right. So first things first, like this is like usually the leading question we always ask the people that we interview. Like, what did you do in high school or like in college, and like how did that sort of end up forming into like your career?
All right, so I've always been interested in space, especially the engineering side of it. In college, I was able to participate in the Space Grant program at the University of Colorado. That allowed me to build small satellites at the time. They were about the size of a microwave. It's before CubeSats were even a thing. And that got me experience working with the hardware and understanding what it would take to actually build and operate the spacecraft. And 2 of them actually launched. Unfortunately, they did not reach orbit, so we practiced. But the whole point of that program in college wasn't to have successful space missions. It was to teach students how to build them, how to operate them, which led to me getting my job at JPL. In high school, I just took every science course I could think of. I was fortunate to be at a high school with a geology lab, and we had some research assistantship independent study courses that we could work with the teacher who was also adjunct professor at the Colorado School of Mines. And that really opened my eyes to the science side of the whole program. So I've always been interested in both science and engineering, which it's nice to work on the Opportunity rover because the engineers get to know the science pretty well. And the scientists have learned a lot about the engineering side. So we all work together. So it's my college and high school experiences combined really kind of led me directly to this mission.
Okay. Just a quick question. Can you hear yourself like through our mic?
I cannot hear myself through your mic. It sounds fine to me.
Very good. Okay, good.
So I wanted to ask about like, what do you think about Elon Musk's like Mars colonization?
Well, Elon has done one big thing for the space program. He's made everybody kind of re-examine what it was. Launchers, it was for the longest time, it was government satellites requiring dedicated launchers, and that's all. There wasn't really a commercial market, but as commercial spacecraft have shown up, like the ones that do the imaging for Google Maps, they wanted more launch capability, and Elon's really forced everybody to re-examine how they do things. He's caused other people to have things be done cheaper. His Mars architecture he's released it's an interesting concept, but right now all of these studies are just studies. The closest we've got is NASA's working on building the big SLS rocket, which should fly for the first time in late 2018. But the more people that keep thinking about it, it's showing that Mars planning isn't stagnant. There was, in the early 90s, an idea of how to go to Mars, which became too expensive, so we didn't do it. Then in the early 2000s, there was a new idea of how to go to Mars, which we didn't follow through on. So everybody putting these ideas out there and actually working towards developing the technology. So even if SpaceX's whole Mars architecture doesn't work at all, they're going to develop a bunch of useful technology for other missions that might help us get to Mars with a different architecture. So it's always nice to have people working on the different pieces of the puzzle on how we get everybody there.
So is there like an interaction between like NASA and SpaceX? Like how do they interact?
So there's a couple of ways we interact. The big one is they are a launch vehicle provider, so we have satellites and we pay them to launch them. That's our main thing. They're working on the commercial crew program, getting American astronauts to launch from U.S. vehicles again. And then there's also the commercial cargo program where they're running cargo up to the space station and bringing it back. Sure, if you've heard of the colonization idea that Elon had, there's also part of what he had mentioned was the Red Dragon mission, the idea to send a Dragon spacecraft to Mars as a precursor. And NASA signed an agreement with SpaceX where we are providing some technical support to help them develop that mission because they're going to demonstrate technologies that we haven't tried yet. They're going to try and land on Mars using nothing but the thrusters. No parachutes, no airbags. It's going to come through the atmosphere, light up its engines, and try and land, which we've never done. And if by NASA spending a small amount of internal money to provide technical support to SpaceX gets that technology proven, we can then use that for our future missions as well.
Okay, so it's sort of like a trade too.
Yeah, it's a very synergistic relationship. SpaceX wouldn't be where they're at right now without NASA's contracts, and they're able to advance some technology faster so they can develop it, and we can potentially contract with them in the future to use that technology for missions beyond low Earth orbit.
So a lot of the people that we have interviewed, like a lot of them, like more technical fields, like engineering or like computer science, like they've all been telling us about how like a lot of things, like especially now, are like more interconnected, and like how many fields are just like merging into each other because of like the possibilities that each of these like provide for one another. So like, is that like, have you noticed that also? Because like I remember you talked about how like you worked together with like other scientists and you guys like shared ideas. So I was just curious, like with your work at NASA, if that's also prevalent.
What I do on a daily basis, one of my main responsibilities is as what we call a spacecraft systems engineer. So I'm in the operations team. So I have more of the general picture of how the spacecraft works. We have specialists that specialize in power, thermal, mobility systems, communications, and they're all specialists, but they all have to work with each other because it overlaps. The radio transmitter requires power, but it also generates a lot of extra heat that the thermal team needs to worry about. The science team has some science instruments that need to be kept warm, so they have to put that near some of the electronics in the rover to ensure that they don't freeze overnight on Mars. And just learning how we enable the science, little tweaks to how we do things. Occasionally I've heard a scientist mention, well, what if we can do something this way? And this is just, at a team meeting, just during a coffee break. And we realized that we could do something differently that can improve how much or the quality of the data that we return from Mars. And we've been doing that on Opportunity for coming up on 13 years now. And because the scientists are willing to work with the engineers and explain what they need, we've been able to get a lot more out of this rover than we would if the science team was fighting with the engineering team and not willing to discuss things with each other. So this more integrated team approach is, I think, the most successful way to do it, because while we may disagree on the best course of action for anything with the rover, we're both coming at it from more of a common point of view instead of both holding to assumptions, and where we may have one assumption that's completely incorrect that's clouding our judgment.
Just to go off of what you and Pratik just said, like I know that a lot of technology stemmed from like the initial like space race, like the 50s and 60s. Like what sort of technology is stemming out of from space exploration today?
So a lot of it, as you said, when learning curve of how do we even build these rockets and spacecraft, we've developed a lot. But right now, a lot of the big developments is some things we're very interested in are machine vision and being able to have the spacecraft be able to see where they're going. There's been development work for the next rover in 2020 where it's going to, during landing, it's using the same Skycrane landing system that Mars Science Laboratory, Curiosity rover used. And it's going to look at images of the ground as it's barreling towards Mars at several hundred miles an hour, compare it to an onboard map, and figure out where it is and figure out how to fly to a safe landing spot. So instead of Spirit and Opportunity landed in a landing ellipse, so our target on Mars was 150 kilometers long and about 25 kilometers wide. Curiosity got that down to 20 kilometers by 10 kilometers. We can drop that down to single-digit kilometers, so we can land in these much trickier locations. But as I found, the scientists always want to go to the hardest point on Mars to land on. So by doing this, we're going to let them see things that they haven't been able to see on the surface before. So that's the big one, is just being able to see with a computer and react faster than a human can, which is going to bleed into areas like self-driving cars, medical imaging, all of that. So it's a lot of interaction between everything. We're also, the space station's doing a lot of research on human genomes and how the immune system works, because it functions differently up there. So I think a lot of the spin-offs seem to actually go more into medical fields than anything else. The old example from Apollo is the CAT scan was invented to inspect parts of the Saturn V rocket, and now it's common in every major hospital.
I have a question. Like, how is your typical day at work?
So a typical day when we are planning for opportunities next day on Mars is I'll get in the morning. The data from Mars will have come in overnight. We don't send data continuously. We just get a big burst transmission once per day. I'll look at how the rover performed, make sure the power levels are where they should be, the temperatures are where they should be. If we did a drive, did we end up where we needed to go? If we're moving the robotic arm, is it safe and wherever we left it? A lot of times we'll leave a science instrument placed on the surface. So once I've established that everything's okay with the rover, I put together a quick summary briefing that will be able to tell the science team and the rest of the planning team what the state of the rover is. It's a lot like if you ever hear a pilot giving a weather briefing. It's very quick, very succinct, all in the same order so that everybody gets all the information they need. From there, the uplink lead for the day, which is kind of my counterpart on the planning team, they will take that information and work with the science team to come up with, do we want to drive, do we want to move the robotic arm, do you have any imaging you need to do at a specific time of day, so we can get all of that put together in what we call a skeleton plan. We then take that to a meeting with all of the scientists, and they, for an hour, will discuss what they want to do. Most of the time they stick with the plan we came up with the tag up half hour earlier, but sometimes they will completely change the plan. I've seen days when we would move the robotic arm turn into drives and the reverse. Sometimes in the last 5 minutes of that hour-long meeting, some scientist will just dial in for the last 5 minutes and go, hey, what about this one rock we're looking at over there? And that will change everything we do. So after that 1 hour meeting with the whole science team, we have decided this is what we are doing today. And then we move on. We start off with ways of making it happen on a lower level. So just kind of coming up, how much power is all of this going to use? How much data is it going to generate so we can stay inside our constraints? The rover drivers, which is one of my other jobs, will come out with an animation of what the drive would look like if we're doing the drive. It's just kind of a sketch, but it's using 3D modeling tools to say this is what we're going to do. We then have a big meeting of everybody who's on the planning team that day, which includes representatives from the science team. We all agree, yes, this is what we agreed we're going to do. This is how we want to do it. Then we go write the code to make all of that happen. We review all of the code because it's a really bad thing to send a command telling your rover to drive 10 meters forward if a cliff is only 7 meters in front of you. We actually have safety checks that will have the rover stop itself if it gets into a bad situation. So we want to make sure all of those are set correctly. And sometimes they do actually stop you from driving off a cliff. We had that happen one time. We got a lot closer to the edge than I wanted to be. Thankfully, the rover was smart enough to say, my front wheels are dipping downward. I should stop this drive. So at the end, we get all of that package together. We hand it off to our mission control engineers who have the call sign of ACE because they used to be the assistant chief engineer. That role became just the mission control engineer, but they're still called the ACE. And they will actually work with the deep space network stations, which are scattered across the globe. Whichever one happens to be able to see Mars at the time that the rover is listening, he'll send those commands up. That'll normally be in the middle of the night here, if it does drift throughout the day. And then the rover receives the command somewhere between 5 and 20 minutes later, depending on how far Mars is away. It'll execute its drive, move the robotic arm, do all of the critical activities, and a few hours later, it sends all of that data back to us here on Earth through one of our orbiters at Mars. It serves as a comm relay. And then we will rinse and repeat, do it all again the next day.
What's one of the biggest challenges that you've had in your career?
So a big challenge I had is I was the first person to really join the project. So Spirit and Opportunity have been on Mars for coming up on 13 years now. I graduated from college 11 years ago. So I had the challenge of coming in as effectively the young kid on the team and having to learn all of this from scratch. I operate a rover and care about a rover I have never seen with my own eyes and probably never will. But just there's a little bit of an overcoming that when you're working with these people that are these legendary engineers at JPL. Most of them are incredibly friendly, but occasionally there's you're this young kid who joined the team. And you have to really work hard to prove yourself. You have to learn everything you can. And that's one neat part about the career. While it's a challenge that you have to overcome the fact that you're learning all of this for the first time about this spacecraft and some people designed it, it's a fun challenge. You get to learn everything. It makes you work hard. as I like to tell people here at JPL, I am not even close to the smartest person that works at JPL. But that's nice. That means I have things to learn. I can improve on things. That was a big challenge. In college, my undergraduate GPA was not the best. I struggled quite a bit in my freshman and sophomore years. And just the persistence to stick with it, to keep going. That's the big thing, is dreams. I've wanted to be an astronaut since I was 3 years old, and I've applied to the astronaut program 3 times, haven't gotten in. But I'm going to keep working on it. I'm going to keep trying to do more things that can improve my application. And part of that has been operating Spirit and Opportunity. But just being able to keep working at it and knowing that these challenges are going to come up, but you may have to overcome them.
Regarding the program, how difficult it is, and what are the processes?
Could you say that again? The first bit of your question cut out.
Regarding the astronaut program, like what are the processes and steps?
Okay, so that's a really good question. I'm going to warn you guys, my battery on my laptop unfortunately seems to be going down a little bit sooner. I'll let you know if it's going to cut off, but I want to warn you in advance. For the astronaut program, it's been interesting applying. The minimum requirements, if you're not a fighter pilot, because that's the only way to make the pilot requirements, is you need a bachelor's degree in science, engineering, or mathematics. Degrees in technology don't count, nor do degrees in geography. I have a friend that unfortunately got into a bind with that. And then after that, you just need 3 years of progressively responsible professional experience. That's all it says. So, first time I applied, I had 3 years and about 3 days worth of professional experience. Needless to say, I did not get in that time. And everybody sends in the same application.
Sorry.
Yep.
I was the school bell.
Everybody sends in the same application. It's a government job application, for better or worse. And then from all of the applications they received, so this time there were 18,300 people that applied. That's the most that have ever applied for a single call. Out of that, there were 12,000 people that were qualified, which is still more than applied any other time. So you've got 12,000 people that have that bachelor's degree and 3 years of experience. From that, they want to come up with what's a group that they call highly qualified. That's about 450 of the applications. So they had to whittle their way down through 12,000 applications to 450. At that point, they check people's references, and then they select 120 semifinalists to go down and interview. After that, they go through the interview results, and that includes medical tests and psychological tests. And they invite 40 finalists to come down for more medical tests for the most part, and a few other interview type activities. And from that, this time, they're going to pick somewhere between 8 and 14. So it's become pretty stringent. And this time, see, from the people that I know that have gotten interviews, it sounds like they're looking a lot more for scientists. Right now, there's a lot of engineers in the astronaut program. And it depends on what they're looking for. If we're going to Mars, they're going to want geologists. If they're focusing on the space station, they may want more biologists and engineers. It just really depends on what they're looking for in any given round. So I know people that have been interviewed one round and then did not get even to the highly qualified level the next round because they were just looking for something different. And it doesn't mean that you're a bad engineer or a bad scientist. It just means that the competition's that tight.
Last question.
Or this is like not really that serious of a question, but have you ever played Kerbal Space Program?
Oh yeah, I play Kerbal Space Program all the time. It's a lot of fun. A lot of people here at JPL play it. So.
We interviewed the guys who made that game.
Oh yeah, the guys who did Kerbal did a great job with it. It is a little bit simplified. That's not exactly how we fly things around the solar system, but it's a great way to get the basics of how all of it works.
Should we call it? Any other last minute questions? First of all, can we take a quick photo with you? I guess we'll do that.
Yeah, no problem.
And also, I recorded this, so would we be able to release this on YouTube?
Yeah, that's fine.
Awesome. All right, let's go.
How's this gonna work?
Hold on. How about you just screenshot it? Because you don't. There's nothing.
Okay, well, screenshot. I think it's Command Shift 4, right?
Everyone just get into frame.
I haven't used this Mac in a while.
It's Command Shift 4.
Okay, I think Command Shift 4. Okay.
Yeah, it's definitely Command Shift 4.
Perfect. Great. Ready? Everyone in? I think no one has to talk because if you talk, the screen pops up. So we'll just be quiet. Or not. Why is it?
You have to drag.
Cameraman. There we go. Close that. Oh my
Gonna
god.
work?
Thighs.
Just like this.
There you go. All right.
Yay.
Ready? And ready. 1, 2, 3.
I guess it's a good
Okay. Oh, no, no.
The
Ready?
dragon.
Oh,
1,
really?
2. Yeah. 1.
Oh my god.
Ah, just stupid.
Hey, there's a camera.
Okay,
You did it.
no.
Congrats.
You gotta be kidding.
I think it'll work.
No, I need to do this. Okay, ready? 1. Okay, ready? 1, 2. Okay. 3. There we go.
There it
Hey,
is.
there we go. Thank you so much.
You're very welcome. Good talking with you.
Bye.